Hi everyone, I'm Sullivan, an engineer on Chrome Web Platform. My team and I focus on the core Web Vitals metrics, and today I want to talk to you about a new metric we're considering adding, interaction to next paint. But first, let's start with some background on core Web Vitals. The core Web Vitals are performance and end user experience metrics. Each metric has three main goals. First, it should apply to all web pages. So for any web page you make, you can easily see its score and get advice on how to improve. Second, it should directly measure some aspect of the user experience. For example, how fast the content shows on screen. We focus on what the user sees, not how the web page is built. We think there are lots of great ways to build a website, and we don't prefer one way over another. Third, core Web Vitals metrics are measurable for real users in the field. They're available through real user monitoring analytics tools, and we publish the Chrome User Experience Report every month so that everyone can get insight into the experience users had on millions of sites in Chrome. We think it's really important to understand how your site is working for real users, and it's a big goal of ours to help you do just that. There are three core Web Vitals metrics. They each measure a different aspect of the user experience. Largest contentful paint measures how long it takes a web page to load. It reports when the largest image or block of text became visible on the screen. This is a good proxy for when the main content is shown to the user. Cumulative layout shift measures how much content unexpectedly shifts around on the page. It reports the worst burst of unexpected movement. And first input delay measures how long it takes for the page to start processing the first user interaction. But there are a few gaps, especially with first input delay, that we'd really like to address. Both largest contentful paint and first input delay are reported for the initial page load. First input delay only measures the time to process the first input on the page. But 90% of the user time spent on a web page is after the initial load. We think we should be measuring that too. We want to look at all the user interactions on the page. And first input delay is only measuring the time the main thread was busy before it could handle the user interaction. We really want to live up to our goal of measuring the full user experience, and here the full experience of the user interaction. That's why we've been working on this new metric. It's still experimental, but we are hoping that it will eventually replace first input delay as a core Web Vital. It's called interaction to next paint, or INP for short. It measures the responsiveness of a website as a user interacts with it. I want to give an example from my own life of how an unresponsive site can be really frustrating. My kid has started taking obstacle course classes, and he's made huge strides. He's competing in obstacle course competitions all over the Midwest now. Here he is at an open gym, where it's easy to see what it looks like when he swings from obstacle to obstacle. Pretty cool, huh? But when we go to the competitions, it's a lot harder to see. The gyms don't always have seating in view of the obstacles the kids are running. And there's a lot of little details that are easy to miss. Here is some actual competition footage, so you can understand how hard it is to see anything. This obstacle is called the sky pipes. They're like monkey bars, but nearly vertical. And that white thing on the first and third bar is a pipe that spins. So the kids have to launch themselves up those 5 bars without slipping. But it's so hard to see. Did my kid's feet touch the floor when he grabbed that first pipe? Did he get to the top one, or did he switch over too early? Did he land on that red platform at the end? Or did his feet slip a little? All of these things could mean he lost the points on the obstacle. I get really stressed out because I know he's going to want all the details as soon as I run up to give him a big hug afterward. Luckily, the judge enters all the scores in real time on his phone, and then I can see them on a website right on my phone. But I'm also super distracted. I'm trying to watch my kid continue his run. And I have a lot of questions from his aunts and uncles that I need to answer at the same time. And then I also want to make sure I have the score right at the same time. And when I tap the menu on the site, it just doesn't seem to do anything. So I think I made a mistake and I tap again. But it was opening, and now it's closed. And I still don't know if he hit that landing platform squarely. This can happen to me 2 or 3 times before I finally get the menu open. I know that the scores might be hard to calculate, so maybe it takes a little bit of time to get the data. But if the site just put in a little skeleton where it will add the content, it will be so much easier to use. And I could be more focused on my kid. So that's the type of user experience we want to measure. But how do we create a metric to do that? Let's start by deciding which user interactions to measure. We want to look at tapping on a touchscreen, typing on a keyboard, or clicking the mouse. We did not include scrolling because scrolling in most browsers happens off the main thread and is mostly out of the web page's control. We'll start by looking at a single user interaction. The user is on a mobile device and they tap the screen to open a menu. In the time it takes for that menu to show up, a lot of things happen. First, the events need to be sent to the renderer. But if the main thread is busy with other tasks, the events have to wait in a queue until that's done to be processed. This waiting time is the delay from first input delay. Then, the event handlers are run. Since this is a touch event, the pointer down and touch start handlers run, if there are any. After that, additional tasks may run. For example, a request animation frame requested in the event handler will run here, along with any other micro tasks. So could tasks that were already in the queue. If the event handlers change the DOM is updated. Big changes to the DOM could cause slowdowns in the renderer. I draw this all as one block for simplicity, but it can be interspersed with the JavaScript work, especially if the JavaScript depends on the changes it made to the DOM. Off the main thread, GPU and raster and compositing tasks will prep any new content to be displayed to the screen. Finally, a frame is displayed to the screen, including any DOM updates. This is when the user sees an update. But we are only halfway done. A lot of the time, all these things happen quickly, and the user hasn't even lifted their finger back up by the time that frame is presented. When the user does lift their finger, the second half of the interaction begins. First, if any tasks snuck in on the main thread while the finger was down, we need to wait for those to finish. So we might have more delay here. Next, there are more different event handlers to run. Since this is a touch event, pointer up, touch end, mouse down, mouse up, and click handlers will all be run if there are any. Then again, additional tasks may be run. And if more updates were made to the DOM, the renderer processes those. And compositing, GPU, and raster tasks happen off the main thread. Then, another frame is presented, and the user sees the full result of everything that happened in response to their tap. The whole sequence is pretty similar for other interactions, except that the event handlers are different. Here's what it looks like for key presses. You can see that when a key is pressed down, there are key down and key press events. And when it's lifted, there's a key up event. Now that we know what's in an interaction, I'll draw them a bit more simply. There's an interaction swim lane in the new Performance Insights panel in DevTools. Interactions in the panel are drawn like this, so I'll use the same style in this presentation. What if the user is a lot slower than the web page? Let's say the user takes a full second to lift their finger after pressing a key, but the web page was lightning fast, and it handled both the key down and key up parts of the interaction quickly. It's not helpful to report to the web page that it took a second to respond when the page was fast and the user was slow. Instead, we need to consider each half of the interaction separately and report what the web page is responsible for. In this case, we'd consider the time waiting on the page for key down and waiting on the page for key up, but not the time waiting on the user to lift their finger. So then, how do we report the value for the interaction? What we would like to report on is the two areas in gray, the key down and key up parts of the interaction, and leave out any time spent waiting for the user. The two main choices are to report the total of key down and key up summed together, or to report the maximum of the two. Because each part can generate a frame in response to a user interaction, we think we should consider them separately and report the maximum. If web pages shift work from the slower part of the interaction to the faster part in order to make the maximum duration shorter, the longest time the user waits for an update is shorter. So we think the metric should account for that. So, for every interaction, we're recording the maximum time from user interaction until a resulting update to the screen. For this interaction, that's the key down time. Now that we know how to measure each interaction, we need to aggregate them into a score for the page. On most pages, there are fewer than 10 user interactions. Since users generally remember the most frustrating interaction, on page loads with 50 or fewer interactions, we report the worst interaction. But what if there are lots and lots of user interactions? We know that the user probably liked the page okay, because they kept interacting with it a lot. And eventually, there are bound to be glitches that cause a poor score. So for every 50 user interactions, we ignore the worst user interaction, and instead report the next worst. That means we're still reporting one of the most frustrating interactions, but not penalizing the pages when they have a very high number of interactions. And that's the details of how the metric works. If you want to learn more, you can see the documentation online at web.dev/INP. Like the rest of Core Web Vitals metrics, we have recommended good and poor thresholds for INP. Ideally, 75% of your site's page loads should meet the good threshold. We look at two things when creating thresholds. The first is user experience research. The existing user experience research we looked into when setting the threshold for first input delay, and the Rail guidelines is still the same. Users expect some response within 100 milliseconds of an interaction. But we also take a second factor into account when setting thresholds for metrics: achievability. When we looked into what's possible on the web today, we found that devices with 2 gigabytes of RAM or less are not consistently able to respond to user input within 100 milliseconds, even on sites that perform very well otherwise. Accounting for achievability on low-end devices, we came to a threshold of 200 milliseconds for good INP and 500 milliseconds for poor. Of course, if your users are on faster devices, we do recommend optimizing to that 100 millisecond threshold. Now that we have a new metric, do we think it's an improvement over first input delay? Yes, we do. We're continuing to research the impact of interaction in XPaint on web users through user experience research and also talking to various sites about what they've learned about user impact as they improve responsiveness. When we look at the data we have in Chrome, if we split users into groups of those who experience good interaction to XPaint, at least 75% of the time, and those who do not, we see that the users experiencing good interaction to XPaint load twice as many web pages as the users who do not. While it's hard to fully pull apart correlation and causation, interaction to XPaint appears to be very well correlated with good user experience. And it clearly meets our goals of measuring more than just the first user input, and more than just the delay. But we also heard a deeper concern about first input delay from web performance experts that we feel interaction in XPaint addresses. That concern is long tasks on the main thread. People from the web performance community often bring us performance test runs like this. There's so much JavaScript running and blocking the main thread. It takes seconds at a time. Why don't we have a Core Web Vitals metric that tells you not to run JavaScript for seconds at a time? This goes back to our goals with Core Web Vitals I mentioned earlier. It's very important to us to directly measure the user experience. If there is a long-running task on the main thread, it may or may not affect the user experience. Maybe it happens earlier in the page load and delays the page from loading at all. That will be captured by largest contentful paint. Or maybe it happens when the user is trying to interact with the web page and the page freezes instead of responding. That's what the delay in first input delay is intended to capture. But first input delay is capturing fewer and fewer of these delays, as frameworks have adopted web platform features, like is input pending, to avoid delaying user input, and as third parties have delayed loading heavy script until user interaction. In the past few years, the percent of sites doing well on first input delay has gone up to over 95%. So is the web fixed? Or is all that main thread blocking JavaScript still a problem? It's a complicated question, but we believe that interaction in XPaint is capturing a lot more of the user pain we're concerned about with these JavaScript-heavy sites. We looked at the total blocking time metric, which sums up main thread blocking time spent in JavaScript's other tasks during page load. We did an analysis of the HTTP archive, taking the total blocking time calculated from Lighthouse for 3 million sites and correlating it to both their first input delay and their interaction in XPaint from real users. We found that interaction in XPaint is much more correlated to total blocking time than it is to first input delay. So sites which block the main thread with lots of JavaScript are performing worse on interaction in XPaint than they were on first input delay. And although interaction in XPaint shows that the majority of sites on mobile have good responsiveness at the 75th percentile, if we split out the head and torso type sites, which are the most popular, we see very different results. Only 26% of the top 10,000 sites are rated good. In the long tail of websites, there are a lot of simpler websites with little JavaScript and great interactivity. But a lot of modern sites, under heavy development, are starting to include more and more JavaScript, both as part of their main bundles and from third parties. And we're seeing the effects of this in their IMP scores. We think it's really important for these sites to improve here because there's a real user experience with slow interactions that users are seeing more often. Okay, so interaction in XPaint is capturing a real user problem. Maybe it's capturing a real user problem on your site. How do we improve it? Before we can improve it, we should first measure it. What is your site's IMP? As I mentioned earlier, Chrome reports user experience metrics for millions of sites in the Chrome User Experience Report. This is really easy to see if you audit your site in the Page Speed Insights tool. To monitor it more closely, you can use the webvitals.js library to do field monitoring on your site. And you can use the Core Web Vitals Chrome extension to monitor the score as you browse. You can also record interactions in the new DevTools Performance Insights panel or the Lighthouse panel to get detailed debugging information. Once you've got it measured, you can start improving it. As I mentioned earlier, interaction in XPaint is correlated with total blocking time. If you run Lighthouse and follow its advice to reduce the amount of main thread blocking script, you'll likely find a whole lot of low-hanging fruit that makes interaction in XPaint better and improves the performance of your site overall. If you haven't taken a look at what JavaScript is blocking the main thread of your page lately, this is the best place to get started. Lighthouse and DevTools can also record your interactions in time span mode and give you audits on those. Here's a video. To try it out, go to the Lighthouse tab in DevTools, select Time Span, and click Start Time Span. Then, interact with the page, clicking and typing until you've done all the interactions you want to test, and click End Time Span. A performance report will show on the screen. If you scroll down, you'll see a section on interactions in XPaint. The diagnostics will show you what's slow and which element was interacted with, so you can understand exactly which interactions are slow. It also gives you some advice in the audits to speed it up. For example, it recommends improving the processing delay here. There's also a link to a trace so that you can dig deeper. As you optimize more, and you fix the things that are easy to reproduce in the lab, in the DevTools, and in Lighthouse, the work starts to get harder. I want to go back to the third point I made about the Core Web Vitals program at the beginning of this talk. Every Core Web Vital is measurable in the field, so you can get the ground truth of what users experience on your site. It's really important to focus on what real users are seeing, so that's what we measure. But most of the tools we use to improve web performance focus on the initial page load, and users interact after the page is loaded. When those interactions are slow, how do you know which interactions and what went wrong? Since we want to improve performance for real users, we should start with real user monitoring. The Event Timing API in Chrome has support for interactions, and our open source webvitals.js library can show you how to use it. I'll show you how you can use it to see which interactions were slow and which elements were interacted with. The webvitals.js library is an open source library you can use to report interaction to XPaint in the field. And it also has support for attribution, which will allow you to report some details on the interaction which was counted as INP. In this example, we're loading web.vitals.js and we're printing to the console. First, what type of event the interaction is from. For example, this could be something like click or key down. Next, we're printing what the target of the interaction was. This is the element the user interacted with. How do we print an element? Here we're going to use a CSS selector so we can find the DOM node that the user interacted with. There are already some really great techniques out there for reporting these CSS selectors of DOM nodes so that we can see the important elements to Web Vitals metrics. The blog post I linked in the slides goes into detail on how to get the most out of that data. You can use tools like Google Analytics and BigQuery to get a list of the CSS selectors of the elements users are having the slowest interactions with. And once you do that, you'll have a great burn down list of problems to debug. So let's get started debugging. In order to make it easier to understand how to debug events, my kids and I put our heads together and we made a really simple game to demonstrate some issues with responsiveness. You can follow the link to it if you want to play along. Here is version 1 of the game. It listens for the click event on the cookie element. When the click handler is called, it updates the score, and it changes the content of the DOM element that displays the score. It's not the greatest code, but hopefully it's easy to understand. So let's open up the game and profile it. We'll go to Chrome DevTools and open the Performance Insights panel. We'll use the Performance Insights panel for this investigation so we can dig into the timeline. But you could also use the Lighthouse panel like in my video earlier. We'll hit record and we'll click the cookie. If we click it quickly, it'll be easier to find in our click recording. Next, just as quickly, we want to hit the button to stop recording. This should give us a nice short recording with just one interaction. Now, let's take a look at our first recording. There are two main tracks to look at to get started. First, the interactions track has the user interaction from our click. We can see that the click and pointer up interactions overlap. If you hover over your mouse, you can see that they only took 16 milliseconds. That's great. That means our cookie clicker is running at a blazing fast 60 frames per second. The game also records user timings in case you want to use a different debugging tool, but you can ignore that track for now. Next, you can look at the main track to get a better understanding of what's happening during those 16 milliseconds. You can see that a little time was spent on the click event handler. Our increased score on click JavaScript function adds 1 to the global score and then updates the DOM. It ran in 1 millisecond. Then more tasks were kicked off. In purple, we see layout tasks that ran because we changed the DOM. And then in green, we see the paint system pre-painting. But if it's painting, doesn't that mean that it painted to the screen? Why does the interaction keep going on after those paint tasks finish? The answer is that the paint tasks are just deciding what to paint. Once that is done, the frame is sent to the compositor and is displayed at the current frame rate. We're running at 60 frames per second, which is 1 frame every 16 milliseconds. So our interactions won't display to the user faster than that. So that means our game is really fast. That's exciting. But my kids are more concerned about adding new features. You know what would be really cool? If the cookie changed color every time you clicked it. And you know what's even cooler? We can do that really easily in CSS. Let's add it to the pointer down handler. Now, we'll open up version 2 and do another recording. Now we see that there are 2 interactions. The first one is the pointer down interaction. It makes sense that this one is shown now, because we just added that. Our change color cookie color function is run as a pointer down event handler. But this is interesting. The function ran in 6 milliseconds, and yet the pointer down interaction took 56 milliseconds. Where did all the time go? I'll let you in on a little secret. we were so excited to make a cookie clicker game that we never stopped to optimize the cookie image. It's absolutely gigantic. And now that we're changing its hue, there's some extra work being done that's a bit hard to see in the DevTools performance panel. If you see a big gap like this, consider whether you might be doing some work on a large image or other things that would hit the GPU compositor. The second interaction is a click interaction, which still does the same work as it did last time. And it ran a bit faster this time. But again, because of the frame rate, the whole click interaction took 16 milliseconds. The third version of our cookie clicker game brings more updates. First, why call it version 3 when you could call it version 3.5730? The kids are really helping me be more creative. Second, you know what's the coolest thing about cookie clickers? It's that you can get an upgrade and increase your score by more than 1 when you click. So let's go ahead and just give everyone an upgrade. It increases your score by 1 plus a random number when you click. Except we want the number to be really random. So we call the random number generator 10 million times. This is super cool, and now our score is shooting up randomly. But it does seem like maybe all those random number generator calls are a bit slow. You can see that the cookie clicker seems a bit out of sync now. When we click, the cookie changes color pretty fast, but then it takes a bit for the score to follow suit. Let's look at the performance panel to see what's happening. The same as before, we have 2 interactions. The first one is a pointer down interaction, which changes the cookie color. But now, the second interaction is a lot longer. We're spending 94 milliseconds in increase score more random, when we spent less than 1 millisecond in our old increase score function. All that additional work slows down the time it takes to display the new score on screen. And that means that there's a noticeable delay when the pointer down interaction changed the cookie color, and then when the click interaction updated the score. I think it's time to talk to the kids about how random number generators work. I used a toy app my kids and I were building as an example of how adding lots of things to your site can weigh down the interaction time and how you can debug it. But let's look at a real-world example of a slow interaction. I clicked on a product image on a web page, and I got a long wait. When I dug into the performance panel, I saw multiple different event handlers running in each interaction. If you're just tracking the time each individual event handler takes to run, you'd miss a lot about how they add up. Make sure you're looking at the whole interaction when you're measuring performance. Here's another slow interaction from the real world. I loaded a news article and opened the menu. The first thing you'll notice is that there's a lot going on here. The biggest pieces of work happening are the load and evaluate script tasks that ran right before the interaction. They're from third-party scripts. They're not part of the interaction at all. They just happen to run right before the start of my interaction, because on this site, third-party code is running all the time. And it really slowed things down. The click event handler had to wait for them to finish before it could run. And this delayed the interaction for hundreds of milliseconds. That's really noticeable to the user. Make sure you're taking a look at the cost of third parties you include in your site. But what if you actually need to do lots of work on the main thread? In that case, you'll need to find ways to break down the work into smaller tasks and ensure they can run at the right priority so they don't block the main thread when something more important, like a user interaction, needs to run. I've linked a great article in this slide that you can read for more details. And that's a wrap for Interaction in Xpaint. I really hope you enjoyed the talk. This new metric is still in the experimental phase, and we haven't made a decision whether to include it as a core Web Vital metric yet. If you have feedback, We'd love to hear it. Our email address is webvitalsfeedback@googlegroups.com. Thanks so much.